Hi everyone, in this new video tutorial about Abaqus learning, we will take a look at simulation of composite material using Abaqus. In this video we will use elastic property of composite material, and also we need to use Hashin failure criteria to simulate the failure of composite material. The result appeared there is represent our result of simulation, and it's take some steps to create this model and get the failure of this material. Hi everyone, in this video tutorial we will learn some basic of Abaqus simulating by simulating Tensil test of composite material. We will learn the basic of simulating and modeling of composite material in Abaqus. First of all, we need to create our part of specimen of Tensil test. We need to go in the part module, part, creating part. Let's add a name in this part. Let's name it composite material, composite. Composite modeling space, we select 3D dimension, deformable and solid, but this time we need to use shell for planar. We need to use shell for simulating the composite layup of our specimen, and click continue. Let's sketch our specimen. Let's add the first point and drag and drop in the second point in the corner and add some quotation. Let's add 80 millimeter in the height and click enter, and add the width of specimen equal to 10 or 20. Let's add 10 millimeter. Now this is our dimension of our specimen. Click done, and this is our specimen for simulation of Tensil test of composite material. We have this specimen. Now we need to add some partition in this specimen. Let's add partition in this face, create partition, face, sketch. We need to make partition for this specimen, shell element with sketch method. When we select sketch, now select an edge or axis that will appear vertical and on the right. Let's click on this side. Now we have our specimen. Let's sketch the first line. The first one, the second one, the third one, and the fourth one. Click done. Now we have the partition of our specimen. Now we go to the module of property. We need to add some property of our specimen. In this time we need to importing the library of our material. We have Hashin failure library, and we need to import this material T300M80 and select it. Copy the material from material library to the model. The material is imported in our model, and click save change, dismiss, and we go there. We have this material in our model. Let's edit the material. We have elastic property of composite material, young modulus in x direction, young modulus in y direction, or first modulus, young modulus, second portion ratio, and other parameters. And we have shear modules of composite material. We have also Hashin damage of the composite material. Hashin damage, we have longitudinal tensile strength, longitudinal compressive strength, transversal tensile strength, transversal compressive strength, longitudinal shear strength, and transverse shear strength with this value. And we have also damage evolution. Let's double click on this. We have energy, type energy, linear. We have also other parameters of our material. We have longitudinal tensile fracture energy, longitudinal compressive fracture energy, transverse tensile fracture energy, and transverse compressive fracture energy. Let's click OK. Damage stabilization parameters. Double click on it. We have this factor of stabilization of our damage. Click OK. OK. Now we need to assign composite material to our specimen. This time we should use this type of creating material. Assign creating composite layup icon. Let's click on it. We have name of composite material. Let's name of composite layup 1. Let's add the initial play count. Let's add 4 play for this specimen. Convolutional shell, we have convolutional shell, and click continue. Now we have this table. We should to add some parameters and data on it. The first, we need to add the region when we need to add this composite layer. Let's right click, edit region, and select the wall part. Click done. Material, we need to add in this specimen. Material, right click, edit material, and select the material we need to add. The third option, edit thicknesses. We need to specify the value of thickness of each layer. Let's add 0.25 for each layer. And finally we need to add the rotation angle of each layer. The first one we have 0, the second one 45, the third one minus 45, the fourth one let's add 45, the fourth one is 90. Click OK. We have this specimen with material of composite. Now we need to show stacking of our composite material and verify if we have the right stacking or no. Let's go to query, click on this icon, query, place text plot, and now we have new viewport, and we need to click on a part of our specimen. Now as we see here, we have the thicknesses of layer. We have the first layer, play 1, play 2, and play 3 and 4th with thicknesses and in the direction of composite structure. We have the 0 direction, 45, minus 45, and 90. Click OK and extend this viewport and delete this viewport. Now we need to go to assembly part, assembly, create instance, apply, cancel. Now I think we need to add some options in our model, like comp-link interaction that need some reference point in the top and the bottom part. Let's add some reference point. Click on tools, reference point, select the first one, create first one, and we need to create the second one, the second reference point. Now we need to add other sets. The first we need to create tool, create set, create. We need to create gauge 1, click continue, select this point there, click done, and we need to create the second set, create gauge 2, click continue, select this point, click done, and we need to create reaction force points. The reaction force point is the point where we need to get the reaction force of our model. Tool, set, create reaction force, continue, and we need to select the reference point of the bottom part, reference point 1, click done. Now we need to go to step, create step 1, static analysis, continue. We need to add nonlinear geometry and incrementation. We add some value. Let's add and change some value. Click OK, and in this part, in this file output, we need to add some features we need to appear in the result. In the wall model, let's create composite layup. In the composite layup, we need to show our result. We need to show some features of composite material. Let's select failure fracture, and we need to select all these parameters of damage of composite material, all these parts, and we need to add hashing failure damage, hashing failure fiber damage. And also need to this option status, XFEM, and status. Now we need to select specifically where we need to show this result. The first one, first ply, second, first, second, third, and fourth ply in our model. Click OK. In history output manager, we need to create another history output manager. Create history output 2. We need to show some result in reference points, in set points. Set, we have three sets in our model. Gauge 1, we need to show the displacement in y direction in this point. Displacement, we need to show the displacement in the y direction for this point. Click OK. The second history output, the third history output, set gauge 2. We need also the displacement in y direction. Click OK. The fourth history output, continue, we need to show the reaction force in this point. In this set we created reaction force, reaction force in the second direction. Click OK. Now we need to go to interaction. I think we should to add some interaction in this part. For this specimen, let's create coupling between reference point with these parts. This the clamping part, the bottom clamp, the top clamping part, and the bottom clamping part. Let's create coupling interaction. Coupling constraint 1. Select coupling. Click continue. Now we need to select the constraint control point. The first point is the master point. Click done, and we need to select the constraint region, the slave region to this point, to this reference point. Select surface, click on the top surface, this surface, and click done. Now I think it's so wrong selection. Let's undo the previous node region. Let's select this part, click done, and we have some data and some constraint we need to add in our coupling. Let's click OK. Now we add the second coupling. Create coupling constraint 2, coupling continue. Select the constraint control point. Select this, click continue. Select this reference point, click done, node region. Select the slave surface to this point, click done, and we have property and option of coupling interaction. Click OK. Now we need to go load step. We add some boundary condition of in our model. Let's create encaster in the bottom part or the clamping part. Click continue. Select the regions for the boundary condition. Select this reference point, coupling with this surface, bottom surface or bottom part of specimen. Click done and select encaster. Click OK. We have encaster in this bottom part or clamping part. The second boundary condition, displacement rotation, initial step. Click continue. Select the point of condition. Click done, and we need to add this boundary condition in the model. Click OK, and the third boundary condition in the step 1, continue. We need to add displacement in y direction. Click done. Click on this y direction and add the displacement in our model, in our specimen 25 millimeter. Okay, we have the right direction of our load or our displacement. Now we need to go into the mesh module and click on it. Let's add the size of our elements. Let's add 1 millimeter of size. Let's add some mesh control, quadratic, medial axis or anything else. It's a simple structure to partitioning. Create mesh and click yes. We have the mesh of our model. This is our specimen for tensile test. Now we need to go to creating group and create our simulation. Create job 1, composite layup, continue. Select any other option if you need, click OK, and finally we need to check our model. Click on data check. Now we have check completed, and before we go to continue our simulation, I forget to add some property in our mesh of our part. In this assign element type, let's go to part, assign element type, select the mesh of our model, click on it. We forget to add element deletion and maximum degradation of our specimen, of our element, and click OK. Click done and go to continue our submission. Click continue. OK, submitted. Running. Although we have an aborted situation of our job, but we have a result. Let's go there. Now we have this situation of failure. Let's animate these. I think we have a problem of speed. Let's make it faster. Fast, apply, OK. Now we have this animation of our simulation, of our results. Now I think we need to plot some result in the viewport, damage, traction. We have many data we need to get from this